This is Dr. Lewis. We're just going to practice a problem about conjugation, one of the topics that might come up in the exam. So this question was about acidity. So remember, we're starting from the basic idea. We've got an acid and it's going to dissociate into its conjugate base, and the equilibrium is really governed by how stable A minus is. Right, it's not really relative to that. So when you're answering this question, whatever you do, don't be tempted to just draw this molecule and draw curly arrows. It's this, the conjugate base, that you want to worry about. So predict which proton of the following molecule is the most acidic by considering the stability of the conjugate base. So it tells you what to think about, and then show the resonance involved in that conjugate base using curly arrows. So there's a lot of protons to choose from in this molecule, and we'll draw them all in. But remember that most of them you can ignore. So any proton directly attached to a double bond is going to be in an sp2 hybridized orbital. So remember, the p orbitals of the pi bond are sticking straight up and down, and the sp2 orbital is orthogonal to that. So anything which is directly attached to a double bond cannot be the most acidic proton, because it cannot be involved in conjugation. So we can ignore all these ones. So then we got a choice of either that one or these two. Now, if you move that proton, the anion will be in resonance with this double bond and also with that double bond. But if you remove one of these two, remember, it's only going to be in conjugation with this C double bond O. So logically, that would be the most acidic proton. So we're going to remove that one, lose H plus. And remember, if we lose H plus, we're left with A minus. So whatever you do, don't be tempted to produce a cation when you lose H plus. It's got to be an anion. So we're going to lose H plus, and I'll get rid of all the H's this time. Yep, so we've got a minus here, having lost that proton. So that's in conjugation resonance with a carbonyl. And it's also in resonance with that double bond over here. And I did a bad mistake there, so remember, that arrow should be a resonance arrow, that arrow should be a resonance arrow. So we've got that now. That pair of electrons has moved into there, so that's now a double bond. That pair of electrons moved into there, so that's an anion. Then we've got this part of the molecule. That curly arrow went into there, so that's now a single bond. And that curly arrow went into there, so that's now a carbonyl double bond. So circle proton is the most acidic. Anion is in resonance with two double bonds. And I think really that's all you need to write.